stream. Always takes a while. So let's see. I push the live button now. Okay, so welcome to Advent of Code Day 10. It's a little later than normal because on Sundays I always have like a dog training with my dog Linus. And yeah, that takes a while. So I went on the training, had lunch with the family, took a shower to catch up a bit, but I'm still not 100%. I really had a bad night's sleep last night. For some reason I really couldn't catch any sleep. I was awake till like 5 a.m. So if I'm not my normal energetic and maybe the code doesn't come to me right away, you'll know why. And it's a weekday or a weekend day, so the issue is probably a bit tougher than normal. So let's see how we'll fare today. So yeah, let's start reading day 10. Pipe maze. You use the hang glider to ride the hot air from Desert Island all the way up to the floating Metal Island. This island is surprisingly cold and there definitely aren't any thermals to glide on, so you leave your hang glider behind. You wander around for a while, but you don't find any people or animals. However, you do occasionally find signposts labeled hot springs, pointing in a seemingly consistent direction. Maybe you can find someone at the hot springs and ask them where the desert machine parts are made. The landscape here is alien. Even the flowers and trees are made of metal. As you stop to admire some metal grass, you notice something metallic scurry away in your peripheral vision and jump into a big pipe. It didn't look like any animal you've ever seen. As you want a better look, you'll need to get ahead of it. Scanning the area, you discover that the entire field you're standing on is densely packed with pipes. It was hard to tell at first because they're the same metallic silver color as the ground. You make a quick sketch of all the surface pipes you can see, your puzzle input. The pipes are arranged in a two-dimensional grid of tiles. Okay, now we have a full mapping. Let me just already copy this because LJ7F, okay. Let me just dump this here as a comment so that I can use that later because we will need it, I'm sure. Based on the acoustics of the animal scurrying, you're confident the pipe that contains the animal is one large continuous loop. For example, here is a square loop of pipe. Okay. So the F is a corner like this, and then the 7 a corner like that, and the L is like this, and then the J is like that. Okay. Haha, okay. You know, there are actually like those shapes in the ASCII table that they could have used, but maybe they were afraid people wouldn't recognize them or something. Let's see. If the animal had entered this loop in the northwest corner, the sketch would instead look like this. Oh wait, what is the S? S is the starting position. Northwest, up left, okay. There is a pipe in this style, but your sketch doesn't show what shape the pipe has. Okay, so that is tricky. If the animal would have entered this loop in the northwest corner, the sketch would have instead looked like this. Okay. So this will already be like some trickery where the S can be any sort of shape. In the above diagram, the S style is still a 90-degree F-bend. You can tell because of how the adjacent pipes connect to it. Okay. Unfortunately, there are so many pipes that aren't connected to the loop. This sketch shows the same loop as above. Okay. So yeah, this one, none of these connect, so that is fine. In the above diagram, you can still figure out which pipes form the main loop. They're the ones connected to the S. Pipes, those pipes connect to pipes, those pipes connect to, and so on. Every pipe in the main loop connects to its two neighbors, including S, which will have exactly two pipes connected to it, and which is assumed to connect back to those two pipes. Okay. Here's a sketch that contains a slightly more complex main loop. So the J is a corner like this. So it's the same bend actually here in this diagram, the same as in the other loop. Let's see. Here's the same sample sketch with the extra non-main loop pipe tiles. Okay. If you want to get out ahead of the animal, you should find the tile in the loop that is farthest from the starting position. Because the animal is in the pipe, it doesn't make sense to measure this by direct distance. Instead, you need to find the tile that would take the longest number of steps along the loop to reach from the starting point. Okay, regardless of which way around the loop the animal went. In this first example, the square loop, okay, so that would be J. You can set the distance from the starting point like this, okay. Here in the example, the farthest point from the start is 4 steps away, and here's a more complex loop again. Okay. So yeah, this will be nice. I think I have a priority queue like this. Here are the distances for each tile on that loop. Okay. Find a single giant loop starting at S. How many steps along the loop does it take to get from the starting position to the point farthest from the starting position? Okay. This is an interesting one. I'm thinking like, do I need to have bit flags to define the shape? Because what I was thinking is, actually I can do Notepad. So if you have like, there are 4 sides, right? You have up, right, down, left. And you could do that with like binary. So like, and have a flag for each set that it connects to. So that you would have a shape, every point would be a byte, and the value would be like a combination of sides that are open, like that. So, and a dot would be just a 0 because it's not set. And I have an extra bit for the starting tile, so that is fine. I think that might be fun. Bum, bum, ba-dum, bum. So let's see. Const byte up equals will be 1 2 3 4 1 2 3 1. So up, down, left, right. And then we can also have like is starting position. And this one can just be this flag. Okay. So now we have our flags, so we can compose them. Const char vertical pipe is this. I should probably copy paste that, but let's do horizontal pipe is. Let me just define them all. And now we create their mapping as well. It's not pile, but pipe. Let's zoom in a bit and make it more readable. Horizontal pipe. And E90 is this. So this becomes L. Let's just set it up. Northwest 90 equals J. Southwest 90 equals 7. And then we have southeast 90 degree bands equals F. Ground is this. And then we do start is S. Okay. And start is a special case where we will have to add the inverse of the neighbors. So that is funny. So we can have a dictionary of byte, byte, inverse is new, and then we can have up becomes down, up. Left becomes right, down becomes up, and right becomes left, like this. So that way, if we found a neighbor, we can take the inverse of that and add that. Say yes. We will also have a dictionary char byte map translation is new, like this. And here we do vertical pipe, comma, and this becomes up and down. Actually, it's or, like this. I will have to test this in a bit, but I think this is all correct. It's been a while since I've done the bit shifting stuff of the binary combinations. Horizontal pipe is left and right. Northeast 90 becomes up and right. Northwest 90 is up and left. Then we have Southwest 90, this becomes left and down. Southeast 90 becomes right and down. Ground becomes nothing, and start becomes start marker, the starting position, like this. Okay, and this one will need needs inverse of neighbor. Neighbors to get the actual openings, like this. Okay. That's also funny because we will need to, if we look up, we need to make sure that it's down. So I'm not even sure if we actually need this inverse map, but yeah, it's fine. Actually, we can take a look at that direction and then we can also map these to grid offsets. So now we have dictionary byte int x, int y, map offset, no, map move. Let's do it like this. Now we have the same, because we will have the we need to map these to moves. Let me think. This will probably need to be a function actually. Yes, let's do this. So we do is byte, byte. Let me think. I will get to that later. Because probably what we need to do is, based on the pipe, generate the relative positions. So it will be list. No, I'm getting ahead of myself. Let's just do this for now. I haven't even taken a look at the input. Nice and big. And let's start with the test input actually. So let's say bool test is true. And then we go here, if test input equals this, right? And we need to change this to S actually. We can also just take the bigger, more complicated input right away. I think that might be better to not baby it. Let's do this. So this is our input. Boom, 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 boom. Now we do input to lines, select. And this one becomes a mapping thing. So we map translation. Why? Like this to array. No, not to string. To array. To array. Var map this. So let's run this. Okay. And now we have our bytes. Nice. So this is the map spit out. Should probably make sure that we find the starting point. So let's do this. Make this available to the actual. Just call this map. I'll just make this globally available so that both parts of the code can use it. And the constructor we set this map. And then we do for let's see, for int row is 0, rows is map length, row smaller than rows, increment row, fine. And then we do for int call is 0. We can actually call this row num, and then row equals rows row num. Like this. Pull it locally. Why not? Cannot apply indexing. Like this. Okay, let's get. This is map actually. Like this. So we pull that out. Length, no, not LCM, so length. Call num smaller than call count. Increment call. Call num. In this case, call equals row call num. If call And now I need to remember, and this starting position, I think it's like this, equals this starting position. So we do int row, int col, starting position. This, and then we do starting position is row num, col num, like this. Then we break, and here we can also do if dot starting position grow larger equals 0, because then we found it. So now we can say console.writeLine found starting position at, and then we do starting position. Let me see if that writes out the way we want it to, at 1, 1. Okay, that is fine. Now what we need to do is actually figure out the neighbors for this and find out their positions. So now we need to do for int row is starting position dot row minus 1. Actually, I can just manual test those. So we do if starting position dot row larger than 0. Make sure there is a row above. If map starting position dot starting position row minus 1, and then starting position dot column down. So we check if this flag is present. So here, check if the pipe above has a connection leading down. And if this is true, we do map starting position dot row and this, and then we do down like this. So this one adds the down flag. And we need to do the same for the left and the right, and we need to verify the bounds every time. So if starting position dot row smaller than row count can I declare this up here? No, I just need to use this again. So I can do int row count is this, and then I don't do it here. That's not what that should say. My apologies. So let's make sure that we can expand to the next row. And if that is true, check if the pipe below has a connection leading up. And this we test with up, up, up. This one becomes a plus sign, like this. Now we need to make sure if starting position dot column is larger than 0, then we can move to the left. So we stay in the same row, but now we do call -1, and we check if this one has right. If this one gets left, and I need to do the inverse for the other ways as well. So if this one is down, it gets up. This one has up, it gets down. Need to stay focused. So we do the same here. If starting position dot call is smaller than, and then we need to have call count, and let's put that here as well. Call count is map 0.length. So now we don't need to do that here as well. We can just use it. If this is smaller than call count -1, we can do this one. Check if the pipe to the right has a connection going left. So if this one is left, we get right. And this one is to the left, has a connection to the right. Boom. And I should probably write a small function to just make this less verbose. Because I really don't like it that I have to put these comments here. I should probably have something like connects down or something, and then you do the starting position, something like that. But yeah, it's fine for now. I'll maybe refactor it later. So now what we can do is console.writeLine starting position just write out what we've gotten and if it works. So this is a small visual test for ourselves. Up, right, down, left. So let's run this. Boom. And now it says we have one to the right and we have one going down. So this is exactly what we want. So far, so good. So now we have the map, we have the starting position figured out, and we have the starting position configured in a way that it works. This one should be made global, because others will need to have access to it. Actually, let me just put it like this. So now part 1 and part 2 both have that. Now is the part where we have to branch off, because there are 4 possible directions that you can go to at each step. And we need to have weights for every step. So traverse one of the available paths, keep track of nodes visited and the visit, and the amount of nodes visited is also your score. So I think we need to do that. So we need to have like a follow path. So this will be int row, int call, and this will be a byte direction. Hash set of int row, int call visited. Let's see. Because this will always also give you the length. And the thing is, let me see. Because one will go around, and this will actually need to be a dictionary int, because we need to know at which stage that we visited that, and then we can compare each node. And what you then have to do is to combine every path source location for each step visited, and then take the highest number for that one, and the one with the highest unique number for a node will be the longest length, I think. Yes. Yes, because that way you will go from all directions, and then you just take the highest number there. No, that is not true. That's a good one. How do you actually know? Because my idea is to loop everywhere individually. So one over here, like the 4, if you go from this side, you will go here. I think I have to look at the data to find a way to figure it out. But what I want to do is track each of these positions, and then get the numbers. And I probably will have to walk each of those based by rank, and then find the collision. I think that's the way that you have to do it. So yeah, I at least know that I'll have the data that I need. So yeah, let's see. But I do need to make something that says like enumerable int row, int call get visitable neighbors. And this one will be this one will just be based on a byte. And this will be a pipe. Okay. So we do if pipe and up equals up. Return. This one will be row, will be -1, 0, and this will be a relative path for every, and I can just call this xy actually, and then it becomes 1, -1, and this becomes the yield return. Okay. Come on. Like this, up, right, now right, down, left, so up, let's see. Good to catch you live, Nick. Welcome, Sunko Suffer, thank you. It's nice to have you here. So yeah, let me just recap what we're doing. This is day 10 for Advent of Code. Let me drop in a link. Basically, you get a map with pipes, and these are the angles. They use some funky characters for some of the pipes, but with a little bit of imagination you can see why. Basically, they have a starting point, but they mark it as starting point, so you have to figure out based on their neighbors what the actual pipe is, and that means that every surrounding pipe that has a connection going to the start point, the start point will have a pipe going that way. So what I did was figure out that, okay, let's use binary numbers here and use bit flags for the features of those pipes. So I have up, down, left and right is a flag in every byte. Right, so you can combine these, and every one of these bits, if it's on, that means it has a pipe going in that direction. I also have one for the starting position. So the starting position starts out with no pipes connected, and then you look at the neighbors to set those flags. I have an inverse map, but I don't think that I need it because I need to do a bunch of manual stuff anyways. Now we have all the characters that the map uses. I have a translation of those characters into the byte configuration with the bit flags. Then I put the map as a global, the starting position as a global, initialized to an invalid position. These I can actually remove because they're named. I've set the test input, and then I translated the entire map to the byte notation. I then cache the dimensions of the map, and I should probably also just put these global because they will be used to enumerate in other spots, so I'll just put them here. Map count, call count and row count, like this, and then I'll set them here. Like this. I then loop through the map to find the starting position, and once I find the starting position I exit out of the loop and I record the position. Then I need to do some bounds checking because you never know where the starting position might end up. So I'll just make sure that I never go out of bounds here, and I'll check if I can go to the upward position, look at that map entry and check if that one has the down flag. So if the pipe above me has a pipe going down, that means I get a pipe going up. And basically, bitwise comparison is like bitwise check means value and bit to check equals bit to check. This is the way to check if a value has a bit set. So we do that every time, and when we find that the neighbor that we're looking at has that bit set, we set the inverse for us. So yeah, I could probably use that inverse mapping with this location and write it a little bit more compact, but for now I think this is fine. I'll revisit this when I find some time. I really want to get through it because there's a lot of small intricate things here that I want to get through. So that I just had a small debug outline, write line to write out the features of the starting position to make sure that we actually parsed it correctly, and that works. So now we are at the point where we'll have to follow that path. And the idea for the challenge is, at your starting point, what is the point farthest away in the loop that you can find? So what you need to do is, at the starting point, start to traverse every possible path. Keep track of the lengths, keep track of where you've been so that you don't revisit the same path. Then I will do, for each step that I visit, I will record it plus the distance that it took me to get there. Once I've done that for all of them, I will compare all the paths and start from distance 0 to distance 1, compare them, and once I find the collision, I'll know, okay, this is the longest path that I can take. So yeah, lots of stuff already happened. So now I'm writing out the get visitable neighbors and this one just takes in a byte and it will spit out the relative positions, and that was what I was doing here. So the X, we have up, right. So if right, the Y doesn't change. If we can go right, the X shifts by 1. If we go down, the X increases by 1. And if we go left, the X decreases by 1. So like this, up, like this, okay. Can align this, but I don't think it matters that much. Like this. Actually, I think it would be nice if it sometimes would just out of format like this, but yeah. I usually then somewhere do this and it's all dirty again. So yeah, let's see. And this will be the point actually. And this one can actually branch off, so it will return, it might return more than one. So var directions is get visitable neighbors for point. And actually this one doesn't, no. I need to do var current is map row call to array, and now we do yes like this. So we actually don't need the to array actually, but that is fine. And then we need to do yield return follow path. No, that is not true, because we need to make sure that there is more to follow. So bool variable path left is false. If not, return visited. Let me see. I need to check here if that position is not in the visited. So for, come on, and I can probably do it like this. Position. Next post is and I can just, let's just keep the same notation here, is position dot row plus direction dot y position dot goal plus direction x, and then I need to make sure that we can visit it, or that we haven't visited this yet. So we need to make sure that if not, visited contains key next boss. Now we can do yield return follow path. This will be next boss. We also need to make sure that we do visited.add position, comma visited.length. No, that count like this. We have this follow path, this, and this will be visitor.clone. Okay, I need to create a clone of that to dictionary. So this will make a copy of that, I think, right? Do I need to do something else? Cannot convert. Oh yeah, okay, sure. for each var path follow in this, like this. Okay. This will probably give me, now that I think of it, this will probably give me a stack overflow, so I will have to do this differently. But for the small example this will work, so let's see what it does. And then here we can do variable pass left is true. So that is fine. Kind of curious to see what this will spit out. So let's just do this. Var path equals follow path starting position. No. Position new. Come on, like this. Pass count. Oh, come on. Pass counts. Length. Okay. Let's see if this works. We have two paths. Count that. That is fine. So now the cool thing is that we need to inverse them. So we do paths.select x dot key. No. Y, come on, x dot select y dot value, y dot key, no, to dictionary, why doesn't it like this, to, alright, okay, so now we need to go, for int I is hash set, because this could be offset, so we'll have to see. Let me see, because it can be that you don't end up at the same spot. So 7, 6, 7, 8. Here's the distance to each tile. Okay. Let me just do it this way to make sure. Let's see, what was I saying? How was it recorded? This is a row call, so same row int call visited is new. Okay, so now we do for int I is 0. No, while true. Int index is 0. So we need to loop through each of those. And once we encounter a path that we visited, we need to stop. Once we both visited those, actually. Let me think. We need to skip the first one. Path dot no. Int max steps is path dot max x dot key. Like this. Why doesn't it like this? Is it that value? Oh, I didn't do the inverse yet. Okay, var inverted is this. So it's like this. And now we can do for int step is 0, step smaller, yes, like this. And actually we need to start at step 1 because we skip the same origin step. So we do like this. If path step visited contains break. This is inverted. Okay, like this. Console. We reached which was already visited. Still not 100% sure if this will be the way, but let's just continue. And this will be path step on step of this step. Yes. And here we do visited.add step like this. I really hate referring to the same thing over and over and over again, so let's just pull it local and use that variable here like this. Okay. Bool found is true. Okay, let's see what this does. Okay, that's not what I expected to happen. Let me check. Max steps is 7. Okay. Oh, wait. What the? How can this become true? That was weird. I didn't see the right line. I didn't see the true happen. Found suddenly evaluated to true without this even happening. How is that even possible? Ah, Jesus. Because I set it to true. I would call that a blonde moment. Jesus. Okay. Okay, so the lowest... So I wonder if it's just the lowest value where they both arrive at the same step, but then you have like the imbalanced one. So for this one it's 4, that is fine. Let's try the more complex one. Because like I said, I'm not sure if I will be off by 1 here or something, but we'll see. Input is, come on, like this. Boom. Okay, let's see. I have something stupid here. Because this needs to be +1. Yes. Step 8. So yeah, okay, I think we got it. Let's try this on the real input. I'm not very confident at this time. Maybe there's no reason to, but boom. Why am I printing all of that out? Stack overflow exception. Yes, this is what I was expecting. So I need to put this in a queue. And I need to know what I was printing out there. Where is the console write line at? I wonder. This will find all the... Let me see. Found starting position, that is good. Let me run this again and just hit pause break. Stack overflow. Okay. Wow, the stack overflow is just writing that big. Okay, that's fine. In this case, it probably needs to be a breadth of first search, but I should probably step one direction in every way instead of completing the whole loop, because I'm doing too much work. Because basically you need to step in each direction and then use the one that has the lowest amount of steps and keep doing that. And once you reach a collision, then you're there. So I should probably switch this up to a priority queue. So this one should be like a queue. Do I have a priority queue in this one already? Priority, let's see. Manage NuGet packages for the solution. Optimize priority queue. I've added it, but I have not used it in this one. Okay. So let me just priority queue. Let me just look it up because it's been a while since I've used this. That's a package reference. It's simple priority queue. Okay. That is fine. Let's see. Let's see. Void process queue. Let's just do it like this. What do I need to know? I need to have the location. This is the amount of steps, and I need to have visited. Basically, I need to have all of this actually. So at the position we have visited, and that's steps taken, but this can be deducted from visited, so I don't care. Like that. So let's see. Q, come on, Q. Removes the head of the queue with the minimum priority. Okay, so that is exactly what we need. So we should do while queue dot count larger than 0. Let Let me think. So we do var current is q.dq. We can just copy all of this here. This will be current.position. And this one needs to be derived from map. Yes. Let me just pull this local and call this entry and do var current is this. You can just copy it like this. Position is entry.position. Okay, so we have that. Bible path lab like this. It doesn't matter in this case. Actually, it does. Yes, and this one will be entry that visited. I should probably also do it like this. Entry that visited that add, and this becomes like this. Let's see if it hasn't gotten the next position. Yes, we've done that, and now we just need to do q.nq. No. This will be entry.visited.count. This. So now we need to have this will be next boss. This one will be entry.visited, and we need to clone it like this. Okay. And this one will be a end path, and I should probably also actually have a global visited here. Yes, actually I could just take visited here and make that shared between all of them, because once we visited something, once we hit a spot that's been visited, that is already the answer. So we can actually remove this here. No, that's not true, because we have unique paths. No, I'm getting ahead of myself. Like this. Let me just keep this the same way as I had it. Like this. So now I can just say process queue and do that. So it's no longer follow path. Where did I call that? In part 1. Okay. So now we do var q is new, and then I need to set up this q thing here. Or I can just call it within, I can just do var path equals, let's remove this, and now I do new like this. Only thing is that I need to have something in there already, so that won't work. So let's do new and grab the type information. So I can do q new q.add .enq, and this will be starting position starting position new, and that's it. And this one will be 0. So here I can do q, and this one should start from there. I should probably verify that the old one still works. Okay, what is this? What is the pass? To array, also fine. Yeah, I can do. Okay, that takes a long time. Wow. Let's see if this is the answer. Woohoo! It works! Okay, so my code isn't super efficient there because, like I said, I think we should have like a shared visited path and then make sure that we stop once we hit that first common one. So like the logic that I do afterwards here, this is the logic that I need to do actually while processing the queue. But I'm happy that I got it. I can always refactor later. Whew. So yeah, part 2. You quickly reach the farthest point of the loop, but the animal never emerges. Maybe its nest is within the area enclosed by the loop. To determine whether it's even worth taking the time to search for such a nest, you should calculate how many tiles are contained within the loop. Okay. The above loop encloses merely 4 tiles. The 2 pairs of the 2 pairs of dots in the southwest and southeast, marked I below. The middle tiles, marked 0 below, are not in the loop. Here's the loop again with those regions marked. Wait. How do they mean it's not within the loop? Ah, because there's an opening there. Yeah, sure. In fact, there doesn't even need to be a full tile path to the outside for tiles to count as outside loop. Squeezing between pipes is also allowed. What? Here I is still within the loop and 0 is still outside of the loop. What do you mean squeezing between the pipes? Ah, okay, so this path here never crosses off. In both of the above examples, 4 tiles are enclosed by the loop. Here's a larger example. Okay. Okay, that's interesting. Let me think. Because I was thinking like a flood fill, but I have to account for the spaces between the tiles. That is interesting. Let me think for a second. That is tricky. Because basically what I would what you would have to do, I think, is to start outside and do a flood fill, and once you hit a pipe you follow the edge. So you follow the edge inside to reach this, but I'm not sure if I can. Let me take this on because this is an interesting example. Okay, so here, boom, boom. I like that this twist completely changes the entire thing that you have to code. So basically, you have to code a whole new solution here. So yeah, let's see if it's run for part 1 still. Do they have an S marked in there? Yes, okay. Okay, so basically you would have to flood fill this. Let me think. Because you will have to follow the edges once you reach them. So for int row is 0, something like this, and we have this actually row count. Just keep it my style for so we do byte row is map row num, like this. Whew. So from the people watching, has anybody done it yet? Always nice to hear from other people. Row. So for int call num 0 smaller than call count. Hey, wow, it got that one right. So basically what we need to do is have another one here. Is outside, and this one becomes another flag here, like this. Okay, so we start if map, row call num call num. So that is easy. That is for the periods. Otherwise, we need to check if the one connecting is still outside. what I actually want to do is follow pipe. Basically what you want to do is follow the outside edge of a pipe and see which tiles you can touch. So I enumerable so what we want to do is we want to position, and then we need to know on which side the pipe it is that we're following. Boom, boom, boom. Because when you follow the pipe, you need to know, you need to location, direction, to follow which side is inside. So let's say that you're, or how do I, let's pull out MS Paint. Okay, let's say we have this loop here. Like a bit what we're doing here. Let's say that we're starting here. We want to go down and we want to make note that to the right is the edge that we're following. So we need to record the location, the direction, and the edge direction. And then we need to, like if we step down, we need to make sure that there isn't a pipe there obstructing it. So if the direction that we're going, if there is a 90-degree angle like opposite to the direction and the side that we're following. So like if we're going down and we follow it on the right, the next that we see can't have an angle to the left. So as long as that's not happening, it's fine. If that one is going down, it's also fine, we keep moving down. If that one goes to the right, we follow it to the right. So that's what we need to figure out. I'm going to grab a quick drink and be right back. So let's do BRB, and I'll be back in a second. Okay, so yeah, this will be fun. So if we do this, every tile that we touch to the outside should be fine, and we should update that. So yes. So let's see. So we have a position where we are. Then we have a int x, int y direction. And we have an int I still think that we should do this with bitwise flags, but it's yes, I can do it like that. I think byte direction, byte, and this will be byte we are following, something like this. Boom, 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 boom. And I think if we do this, if we trace outside and we yield all the tiles to the side that we can mark as is outside, we can then do a second pass to find all the is outside tiles and just connect all the ones that are blank directly connected to them. And I think that should be it. So we do first follow the pipes, and then we do a how do you call it? Then we do a flood fill based on all the other ones. So yeah. Dun, 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 dun. So we do var next is get possible, how do I call it? Get visitable neighbors, okay. So this one is get visitable neighbors direction. And this should also always just be dot first actually. So now we need to do var next tile, tile is map. Next we need to have position. Var next post is position dot row plus next dot y. Come on. Let's do it the same way. Position dot goal plus next x. I should probably make out this type because it won't be a strong type otherwise. We need to make sure that we are within bounds. So we do, and I have all of those here actually. Don't I? Let's see. If next post dot row larger equal to 0 and next post dot row smaller than row count, and next post dot goal larger than 0 and next post dot goal smaller than goal count. Okay, so this means it's within bounds. Bounds check. Now we have next tile equals map next post dot row next post dot col, like this. Okay, and now we need to ensure that if I bring up this one again, we need to make sure that that pipe doesn't have one obstructing us. That would be the inverse of the pipe we are following direction. So if next tile is no. Let me see. Yes. I need to have something to rotate these. This is funny. So we can do byte, rotate, rotate right, byte val. Val equals, and then the top one is actually right. Let's see. It's too bad that I masked these wrong. So I need to do up, right, down, left. Let's just change the mapping. So that we can actually rotate with it as well. So we start up. So if our rotation is left, we return up. Otherwise, we do val shifted one to the left. Into byte? Why not? What's wrong here? Byte. Same for rotate left, so I do byte rotate left. Byte val. Val is up. Becomes left. Otherwise, we do byte val shift one to the right. Okay. And this should probably be a bool to indicate that we're following it on the left or right side. Bool following on left side. Because this will let us do take the inverse. So if next tile and let's see, var barricade is rotate right now. Oh yes, if it's left, following the left side, we need right. So it would be rotate right direction. No, rotate direction. Otherwise, rotate left direction. So now we can check if it's if there is a pipe coming across. Try to follow. Else if let's see, var corner is, this will be the inverse of this actually. So it will be rotate left. This one will be rotate right. Next tile and corner equals corner. Try to follow the other side. Else if I don't think there's the other option has to happen here, and then else throw new application exception can't happen. So let's see how fast that exception throws. It's always, if you say, well, this can't happen, it will happen. Because basically if you're following a pipe system and it's always a closed loop, but we're not sure that it's always a closed loop, we have to actually get to the pipe system. It's actually funny because we'll have to find if not sure yet. Let me think. It's such a tricky problem, this. Let's see. Else we expect next tile to at least have the same directionality as we have, and direction is direction. Pipe follows path. Okay. Just trying to think what else could happen here and how we do this. Let me think. Because the pipe we already know that the pipe that we're following should go down there. Let me see. We should check the pipe that we're following, what that one is doing actually. So we should actually be offset by this one. Oh man, it's hard to wrap my head around it. So let's see, if we're following here and we want to check this section here, we actually need to check this section of pipe and to see what it's about. If that pipe moves to the left, we can't go down one more. We need to also follow to the left. Well, actually we can move one down and one to the left there. No, if the pipe moves left, we will have to follow that one. So we do two steps actually. We go one down and one left because we have to follow the outside edge. So if we're here and the pipe below it goes to the left, we have to take two steps and then update our following direction and everything. Oh no, we can move to this one and then set that state. And then we have this one and then, so we need to trail behind one. Right? Let me see, if I have like a pipe that goes like this, boom. And we are evaluating this pipe, this section, right? Let me just draw, these are pipe sections. So we are here and we've determined that we are going this way. So we're on this side and we have the pipe edge on our right. So we're moving down, pipe edge is on our left if we look at it. So we're following the left side of the pipe. Then we need to check the next pipe in that direction, which becomes this one. Well, we can always move in that direction because we know where it's going, right? We check the current one if they're yes, so then you move to this one and then you check, is there nothing crossing to the left? That is fine. Is it going to their right from that side? If it's going that way, we need to follow it unless there's a T section here as well. So actually we need to go from the way that we're looking at it is we follow the pipe and then we need to take the direction and away from it check first. Does it go that way? If it doesn't, fine. Does it go this way? Okay, because if it goes this way we need to follow here. Then we need to check, does it go there? Then we need to follow there. it doesn't matter what res it does, and then we need to check this, and if it does that, we need to follow there. And if it doesn't do that, then we're in a state that we don't understand. So, okay, we first need to take the barricade, so that is like, it follows to the right. So if we're left, we need to check the right angle if it has that. Okay. Else, we need to make sure else we need to check if it's still going straight, right? Follows path, and otherwise we need to follow it along the corner. So these are the cases, and then we have the situation that should not be able to happen, but yeah, let's see. So in this case, position is, and then we need to move one in that direction. Is I should probably have something like int row, int call, add int x, int y to add. And it's stupid that I mix these up here. So let's just do position dot row plus to add dot y comma call and x. Okay. I could just do combine like this. At least this saves me a bit. So now position is combine position with in this case barricade, and this will be get visitable neighbors from barricade first. Actually single, because there should only be one answer here. If it comes back more than one answer, it's not correct. So now we update our position, which is cool. And we should probably change our direction as well. So direction is barricade. Yes. We've done that. Nothing needs to change. Actually, that's not true. We do position. Come on. Position is combine position, comma, and this will be the next boss. Actually, position becomes next boss. Okay. And this should probably be in like a loop. And otherwise here we have the same, and then we do this. And now what we should probably do every time we do this is to make sure that we check for but for now, I'll just emit the outside, the follow pipe places here. So I'll just do yield return position like this. Our start is position. Let's see if we get back to the, if we ever get back, that we break out of it. So I can do while position not equal start. Constant upper limit is 100,000. Int loop count is 0 and loop count smaller than upper limit. Let's just make sure that we have that in here. Let's see if we can get this to work, right? So let's say var pipe outer is follow pipe, and we do start position down to, and I don't actually know the starting position here. Yes, let's just do that and try to walk that section here. Let's do console.writeline outer size, boom, and then we do pipe outer array to array okay. Let's see if this even works. Boom. This can't happen. Great. So now we're in a position and I can't even know how many. 6,2. Start is 1,1. Okay, so at 6,2, let's see. 1, 2, 3, 4, 5, 6. Oh no, it's down, right? 1, 2, 0, 1, 2, 3, 4, 5, 6. 1, 2. Okay, here. So here we have a pipe. Yeah. But we shouldn't be able to follow that, so we moved 1 too early, I think. So if the logic, okay, yeah. So our logic needs to do that one step later. Let me see. Boom, 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 boom. No, wait. Next pulse. I actually don't think we need this at all. This just needs to be positioned. Tile position actually becomes this one. Direction, let's sing that. Okay. Boom. 46 steps. That is pretty cool. So my loop and following code actually effing works, which is sweet. So sweet. Huh, nice. And what we need to do now, of what I want to do, is that we check to the outside, to like the place that we follow, the perimeter that we follow. If that is a 0 tile, we convert it to is outside. I'm actually pretty happy that this worked. So I wrote code that can follow the path, so that is pretty sweet. My only issue is that in the bigger example, there will be other loops and stuff. But, yeah, there might be, no. I'm just thinking if there's like another loop that messes with it, but I would just take the starting position and follow that loop and just make sure that we can consider everything outside there as outside. And let's see if that works. Might have to do another step, but I think it's okay. Let me think. Yes, let me think. Boom, 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 boom. So in our current position, I'm just thinking, going back to here, if we are here and we are checking this outside, then we should be able to check this spot, like this spot, to see if this is outside, right? And if we're here, we should actually check more than that. So I'm just wondering now if we should always look ahead. So like, if we know that it curves like this, we should check this spot and this spot, right? And then if we know here that it curves to the right, we can only check this spot again. Then if it goes to the left, we can check this spot. And then once we go here, we can check this spot, this spot, this spot. So let's see, say if this one goes up here, then we can check this and this. Okay. So if it's at the same, if it goes this way, we can check this side. Yes. Let me see how I do that. How do you codify that? So if it's either going straight or following to the left, you check to the right of the direction that you're going. You always check to the right of the direction of you're going when you're following it on the left hand side. Okay. Let's see. If we're following on the left hand side, we want to. So barricade is always the spot where we want to check, actually. So so we can do tile to check for empty is position combine position, comma, get visitable neighbors from barricade dot single like this. So this is the location where we want to check. So this will also be this. Tile to check for empty. But based on the current one that we're at, that is only if we look ahead. Let me think. Let me go back to the, I closed it, didn't I? Yep. Too bad, I closed my drawing. So let's draw this out one more time and make sure that we do this correctly. Like this. This isn't the perfect example, but let's say that we are on this side following so we know that the direction to follow is down, so we could always check this side, and in this case we will be following here, so we can always check this side. So yes, the tile that we're in on the right is always the place to check. Because that's after, right? Okay. So yes. So this is only for the current one. If the current one moves, tells us to go that way, but our direction is different. Yes, based on our current direction. Yes, drag to. So this one is still the tile that we need to check. Maybe I'm wrong, but let me just make sure that if so var tile to check for empty is combine position, comma barricade, and this one is get visitable like this, single, and then we do if map tile to check for empty dot row, tile to check for empty dot call equals empty. No, I just called that 0, right? Yes, is 0. Then we can say is empty tile. No, is outside. Is outside. Yes. Cool. And now, in a second pass, what we need to do is to find all the. Do this again. So, and now we need to do if this one is outside. Check all empty make them outside too. Okay, And basically these need to follow in each direction until they are not. Because it needs to flood fill in each direction, so that also needs to be like a probably with a queue. Let me see. Void mark empty neighbors int row int call boss, something like this. If empty, something like this. So what we can do here is if map row comma boss row boss call is empty, actually 0. Then we can do okay. That's my coffee machine in the back saying I've had enough. No, is outside, and then we need to do all directions from this and queue those two. Actually, we can do a hash set. No. Let's keep track of which ones we've done so that we don't end up in an empty loop. Processed. Queue. Okay, let's do that. For each var pulse in queue. This process.add post like this, and then we need to have all 4 directions, and we need to have the map bounds checks. Can I copy that from before? I'll just write it again, it's okay. So now we need to do it like this. Var neighbors is get visitable neighbors, and this one will be up or right or down or left. So we do for each var neighbor. We can just do this actually. Post is new post is combine like this. If not process contains new post. Queue.add new post like this. Okay. So this one will add and keep growing to each side to make sure that it checks them. So now we can build up this queue here. If it's outside, we add it to the queue. So we do row num, comma, col num. And then we do mark empty neighbors if empty, queue, comma, new. Like this. This one should go out and tag all the ones that are not empty. And then we need to find the ones that are inside our loop. And there might be ones that are in another loop, which is a pain in the behind. Because actually we should probably loop on the inside of the loop and then mark them, and not on the outside like I'm doing now, but I just realized that. So yeah, I should probably have done it the other way around and catch the inside of the loop and then make sure that we tag everything. Darn it. I'll check that in a bit. So now let me just go to do map.select. No, actually map, yes, dot, no. X dot where y is outside. Sum, no, count actually, and this will be sum. Outside is this. Tiles marked outside. Outside. Let's see if this works. $53 of them are marked outside. And now we should find the ones that are marked not outside. So inside, where they are 0. Inside, inside, okay. None of them are inside according to my code. That's great. I wonder how that's possible, because if we follow this along the edge, wait, let's see. Yes, if we follow this outside, it should never mark these. That's interesting. So 0, 1, 2, 3, 4, 5, 6, 6, 2. Let's see. If tile to check for empty dot row is 6. Let's just do system.diagnostics@debug.writeLine. So this won't mess up with the empty line. There you go. Okay, so that is interesting. How is it possible that it's never this one that marks it? So that is good. Let's see. And this one also never fires. How is this possible? Okay, let me see before this all happens. Ah, this one is messing everything up. Okay, my bad. Because this one marks everything outside, which is wrong. Okay, let's try that again. What is the call? 0 is fine. 5 is also fine. 10. Is that true? Let me see. We have 16 inside tiles here. Okay. That is not great, because I think that will means that it has this one. So 2, 4, 5, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. Let me see. So it never did these ones. So if it follows here, it should go around here, and then it goes to 1, 2, 3, 4, 1, 2, 4, 2. I think 4, 2 is where I need to have my check. Position.row is 4 and position.call is 2. What's wrong? Okay. So this one, tile to check for empty becomes 4, 3. So this is 0, 1, 2, 3, 4, 0, 1, 2, 3. Boom. Oh, wait, what? So what is the value for this one? 32. How is that? What is 32? That's a good one, because now I need to make sure. Dun, 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 dun. It's marked as outside. Why is it marked as outside? I mean, it's correct, but what piece of code did that? Ah, this is wait, that didn't fire yet. How is it possible that it already did that? Let's go back to the drawing board. Boom. Let's take map. 4. See, these are all zeros still. That is fine. Like this is outside, it's only marked there, right? This one hasn't fired yet, so that can't be the case. This is the only place where this happens. Okay. So this is 0, okay, let me just do console.writeline marking blah comma blah as outside. Following pipe in direction blah. Tile to check for empty dot row. Actually, I can just do this. Position and the direction. And this one becomes. Let me think. String direction to name by direction. So this one should be direction switch. Can I do that? No, I'm not great at that. Let me just do if direction and up is up, return up. Argument exception, invalid direction. Okay, up, right, down, left. Oh, is that right? Right. Okay. No. Okay. So this is all fine because it starts doing this. And it's funny that it skips 2 actually to the right. So it misses this one below it actually, which is let's see. This one goes to the left. Then it goes there. Interesting. Because once the shape moves, it should also check this one. So we should probably, when the angle changes, we should probably do the checks based on this one here, on the new direction. But yeah, that's fine. So yes, this one goes to the right. So it follows the bottom row, like 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is fine. So it follows the bottom row. And then it goes to 6, 5. So 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5. This is this one. That is good. So 6, 5, then 5, 5, and 4, 5. And then we have 3, 4. So it's 1, 2, 3, 1, 2, 3, 4. That's a bit weird. 4, 3 actually. No. 3, 3. Am I switching the rows and columns maybe? I don't think so, but the thing that we want to know is like 1, 2, 3, 4, 5, the 6 column, 6 row, and then 1, 0, 1, 2, 0, 1. So 2, 3, 4, 5, 6, and 7, 8. So 2, 3, and 7, 8. So 6, comma, 2, 3, and 7, 8. 6, 10. So these never happen, so that is good. So these inside, these two are never marked as inside. So that is good. But 0, 1, 2, 3, the 3 and 4s, I think there's a lot of them that are marked, right? Okay, so that's interesting. So the code so far has done well and not touched those two. So let's see, where is our code now? Call stack. Oh wait, I probably add these in the wrong way, right? Row call. No, okay, that is fine. Let me see. Because the queue six zero, but it also has 6 5 and 6 10. Oh yeah, that is fine. 6 5 is the center one and 6 10. So yeah, this is all correct. So how is it possible? Let me just okay. Okay, so there's just a few more inside except these, but the inside ones, let's see which one it has here. Select many. Where is 0. Wait. Oh yeah, I need to have the locations here. Okay, let's loop through this one more time and print out the ones that are... Actually, we could do console.writeLine. Let's see. Console write. Let's do 0. Else if row call num is 0. Console.writeLine. Like this will be an I, else we do console.write, and it needs to be write, not write line, for both of these, and this will be a space, because I don't care, and then we do console.writeLine. Let's do this. Okay, so this one should give us the map of what it marked and hasn't marked. So let's just get rid of all of this. Boom. Okay. So this is funny. So at the top, it didn't manage to map those. So the flood fill thing that I wrote didn't work. But it did catch that those two should be inside. Okay. I think my mark empty. Okay. Let me see. directions is direct to array. Come on. To array. Boom. No, I'm curious. So I wonder why, because these ones should be able to flood to the other sides. Bum, bum, bum. And my breakpoint actually didn't hit, which is also weird. Ah, okay, let me just... the issue is that I add the ones that are already marked. Boom, 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 boom. Let me see. I can do away with this. I need to do it like this. I need to check that if it's all marked. Oh yeah, that's true. And I can actually do just I should make this actually just a queue like this, while queue dot count larger than 0. Pulse is, come on, pulse is Q but DQ, come on, DQ like this. See, this is fine. This then becomes NQ. I need to change the type of this call as well. This becomes a queue of that, and this becomes NQ. Okay, let's run this again. Index out of it. Okay, so now I need to make sure that I check those bounds. And I actually need to do this here. So if new pause dot row larger equal to 0 and new pause dot row smaller than row count, and new pause dot call larger or equal to 0 and new pause dot call smaller than call count, and then we can do this. We can do this combined. Let's run it again. Boom. And now nothing. Nice. So now somehow this got connected, which is wrong. So now we need to do this. It needs to be a few things actually. So we don't, need to make sure that we haven't seen it yet. And map new pause dot row needs to be actually is outside. Otherwise we don't want to process action. No, is that true? Let me see. this is fine. What we need to do is make sure that if this one is outside, so if it's already outside, or if we turned it outside, then we need to check its neighbors. Oh, and now we have an infinite loop. Okay. There's something wrong. Okay, there was something weird going on. And now we have 4 inside. Woohoo! Hey Smap UK, welcome to the madness. Oh, today was a tough one. But now I wrote my code to follow the outside, which might be an issue because I probably need to follow the inside. So now I need to turn off all the debugging and run it for the real problem and see if there's more for me to do. So yeah, that will be that might be a tough one. Did you do today's challenge, Smap? I've been there, yeah. Okay, that doesn't give me a lot of confidence. That probably means that I need to, yeah, switch from outside to inside as well. Okay, I just want to turn this off. Let's run it on the real input and get disappointed. I did. Took me ages. Yeah, I can imagine. I mean, I've done a lot of stuff that I like. Boom, boom, boom. Okay. I missed something, I think. Let me see. That is fine. That is fine. Invalid direction. We can take this away. But this is well outside my experiences. Yeah, it's not like I've done this before. I need to write this. Let's run it again. I had to look up a few algorithms. I now have 2 working methods. Ah, that's cool. No, there's no lookups here, just coding away. I just hope that this works because I'm afraid it won't. Nope, it's too high. Dang it. So I need to check the inside probably. But I had a long time where I had some tests passing, but not the others until I had an epiphany. Okay. So now what I want to do is actually do my logic on the inside. Let's see. Follow pipe, and I can say false. And I think this should give me the inverse answer. So 28 would be the answer here. Jeez. Okay, that sucks. Okay. I'm going to be cheeky and I'm going to do it like this, and I'll actually turn back on my console printing. And let's make sure that this becomes really big. Boom. Because what I probably should do is, because it counts on the inside a bunch of stuff on the outside here, which it shouldn't. But now the only problem is, what would it be? I think if you're a game developer, this problem is easier. Not per se. So let me see if I do this again on the inside. I wonder what it spits out. And I should probably also take because these zeros are now the things that it marks as being inside, truly. So everywhere where there's a zero now, and I wonder if I should invert my expansion of that as well. Because I should probably fill out the inside ones. I don't do that right now. So let me just try and see if that works. Let me see. Mark neighbors empty. So I can do byte mark. Mark. So this is outside, and I should probably do the same with this zero actually. Is that true? So now I should be able to, where is my code? So the first one I do is outside 0, then I do 0 is outside. So I think if I run this twice, it should expand both. Wait, that is wrong. This is the outside Q, then I do inside Q is new blah. Else if row column is 0, inside Q dot, I should probably do that after, yes. So first I need to mark everything, the outside stuff, and then I need to do for the inside. So everything that's still 0, I need to expand that. Let's see, this becomes inside Q. Actually, let me think. Does it make sense what I'm saying? Because if it's no, that's not true. I don't need this at all. because if I do the inverse run, it would have marked the inside ones as being outside and expanded those already. So that's not the issue. Boom, 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 boom. Now I'm a bit stumped at this point because I have the code. I've written the code that follows the map. I've written the code that follows pipes, so that works, which is cool. And I've done it for the test input, which is also cool. It works on the test input if I follow the outside. Let me just do the follow the inside of the test input actually. Let's do that and see if it works as well. True. Let's spit out. So yeah, this works, but do I have it following the outside or the inside right now? Yeah, either way works. So my follow code works for both following the inside and the outside of the loop, which is annoying. Because actually for this one it should just a second, let me following on the left is false, so that means I would follow it on the right side. Okay, let me see, follow pipe, because this one should only happen 4 times. No. Okay, let me see. This becomes 8. This one is 2. So why is this one 8 when I'm not following on the left side? Wait. Ah, okay. This should be false because I'm following it on the right side. Okay, my bad. So 0, 2 is not something. That's interesting. Because direction is down, so barricade. Let's see. It was down, so then it should be right, not up. Oh, but direction is 2. Where are we going? How many steps have we already taken? We're at 1,2. That's weird. Okay, let me just start at the beginning and see. Maybe my inverse logic here isn't correct. Okay, let's see. So we're at 1, 1, which is this one. And I say we go down, right, up, right, down. So 4 is down. And I'm following the right side, the right wall. So I'm on the inside here. So the one that we should check for empty, yes, that becomes this one. 1, 2. So that is fine, because yes, once we go down, we are at this side, so we need to check if on our side are empty tiles. So that is fine. Boom, 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 boom. The direction's not that way, okay. Ah, okay, because it says it follows, but I said it was moving down, so it shouldn't matter there. I should have started at 1 further. Let me see if this is the issue. If I go here, combine, starting position, and then we do 0, 1. So we have 6, 2. 6, 2 is 1, 2, 3, 4, 5, 6. 1, 2. Okay, boom. Nice. And this should be inside here. Okay. 6, 3. So that's the other one here that it hits from checking the inside. 6, 7. So 1, 2, 3, 4, 5, 6, 7. So it hits this one. Six, 8. Wait, did I count wrong? 0, 1, 2, 3, 4, 5, 6, 7, 8. That one's not possible. That's weird. 0, 1, 2, 3, 4, 5, 6, 7, 8 is not. This can't be a 0. Wait, what? Let me look here. So it's 0, then a 5 for this one, then 2 times marked outside, then a pipe. This one is marked 0, that is weird. Then an outside, then a 0. This one is... Wait. 0, pipe, 2 of those, 2 of those. There's a 0 between those 2 in here, that's weird. How's that possible? It's like there's an extra character in the input. What happened? Oh wait, I copied some wrong. Huh? It's a different map that I'm looking at. Let's see. That's not the. That's not the hard sparse map. It's this one. Okay. Okay, that is fine. Makes sense now. So now you can see it marked all the outside ones and it left those two. So, yeah. Okay, so now the case where it's closed. So I just need to delete one of those sections there. I didn't test this apparently. Let's see if this also works. Yep, this one also works. If I run it the other way around, it also works. So, yeah, that's a bit annoying. Because I think I need to have this representation, but I just need to invert the logic. I just got a message that one of my daughters is sick, so I'll end it in a few if I don't get it now, and see how things are at home. Index out of range exception. That's interesting. Oh, so we're checking along the edge, but I don't check if it's a valid. That's annoying. Bool is within map bounds. And this one is a row call common. Blah, blah. Let me check. I've written this a few times. Let's see. Yes. Okay. So now I can just do this. Boom. And here as well. Time to check for empty. Okay. Yeah, this is a tough one today. So I got 72 now. So this will be my last attempt. Not the right answer. Okay. Okay, I'm done. I might revisit this after looking at some of the Reddit posts and see how people attempt this. I'm really happy with the code I wrote, like everything that I've done so far. It's pretty cool that I got it to work at least on the input and following the actual methodology, so I think that's pretty cool. But yeah, obviously there are still some areas where my algorithm is lacking, so yeah, I will revisit this later probably. So for now, I want to thank everybody that kept me company during the stream. Smap and Sunco Software, thank you. Others that didn't chat, no worries. It's nice to have some people watching the stream. So I've had fun with this one today. I've written a lot of code and all of it works, except for the final input. No, but like the thing that I want the code to do, it does that. So there's just some edge cases that I'm missing. So I will revisit this later. But yeah, for now, thanks everybody for watching. It's been fun, and hopefully see you tomorrow. And maybe then I'll have an update. But because usually when I don't get it right away, and Tarun Pandi says, Yo Tarun, welcome to the stream. I'm about to end, so I'm sorry for that. But usually with these cases, when I don't get it, the problem keeps nagging at me, and I'll revisit it later in the evening. But yeah, I think it's time to cook some dinner for the family, check out on my girls, and yeah, I will check later. So thanks everybody, and